Okay, so what I've got here is I've got a couple of Ultrabat power blades configured into a battery. I've got two of them configured here in the battery, and they're designed to, the modular batteries are designed to snap together to build you whatever size battery you want. Two of them here, the specifications say that we should have a rating of 180 cold cranking amps, which they just call 180 CCA, and that's a measure of how well a battery will start your bike. I've got the batteries here hooked up to a load tester, and we can set the load tester to 180 amps and draw that current from it and watch the voltage drop over a period of time. A CCA test is defined as a test of how much current, the maximum amount of current you can draw out of a 12 volt lead acid battery before the voltage drops to 7.2 volts at 0 degrees Celsius. We're sitting at 18 degrees Celsius. The difference in performance between these lithium batteries, the performance is less at 0 volts than it is at ambient temperature, but I guess we're more interested in ambient temperature starting, and it's fair enough to do a test at 18 degrees Celsius and then go and get a lead acid battery or another lithium battery and compare the performance at the same temperature. So we're going to see if we can draw 180 amps, which is what these batteries are rated out of these batteries for 30 seconds, and at the end of 30 seconds we're going to see what our finishing voltage is. So I've got a voltmeter here hooked up to the batteries, a digital voltmeter, and we're starting off with 13.2 volts on these batteries. Lithium batteries usually sit at rest between anywhere from about 13 volts up to about 13.5 volts is pretty typical. So these batteries were charged up a while ago. Okay, so what I'm going to do is I'm going to dial up 180 amps on the load tester, and we're going to run that and at the end of 30 seconds we're going to have a look at how many volts we should have. And of course, if these batteries are really honestly rated at 180 CCA, we should have 7.2 volts left at the end of the test. That's the test for a lead acid battery, and seeing as this is a replacement for a lead acid battery, it seems fair that we should expect the same sort of performance from a lithium battery, or perhaps we'll get something a little bit better. So I'm going to turn on the load now and wind up the amps. So we're just doing this here now, and I'll wind that up to 180. This is quite a good load tester because it'll maintain the constant amps even while the voltage drops. So there we go, the voltage is just up, the current is just up there. I'll start my stopwatch and away we go. This load tester beeps at 10 seconds. Or thereabouts, a little bit quicker that time, because that would be normally what a pulse test would be, but we're doing a full CCA test. So we can see our voltage here is dropping down to 9.87 volts at the moment. And we stopped at 9.7 volts there. Turn off the meter, and our voltage now climbs back up again with the load taken off it. So the batteries are performing significantly better than their claimed rating, which is not unusual for Ultrabat. We've seen this in the past. You may have seen on the internet tests of other lithium-ion batteries doing load tests of this nature, and it's probably best to say just go and have a look at those tests and see what happens, but they don't perform like Ultrabats. In some of those tests we've seen, you'll see what you see. So thank you very much.